Okay, so hello everybody, welcome to another one of our live tech talks. We've got a slightly different setup today, so hopefully it's good for everybody. I'm Kevin, and today here with me is Alasdair, who's one of our designers.
Hi there.
And we're going to be showing you one of our new products, which is an air quality board for the BBC Microbit. Do you want to just give a slight overview of this board, Alasdair?
Yeah, definitely. So this is, as Kevin said, it's for the BBC Microbit. It's another one of our accessories for that product, and it is an air quality monitoring and data logging board. So it's got some memory on there, it's got some sensors on there for picking up that climate and environment data, and it's also got a nice little display for giving you some output readings. But we'll go through it in a bit more detail in a minute, and I'll show you some of the features on the other camera.
Brilliant. Yeah, thanks, Alasdair. Obviously, we're live on YouTube, so if anyone does have any questions, please feel free to type those in. We've got Mark here looking at the comments, so he can relay those messages to ourselves, and myself and Alasdair will do our very best to try and answer those for you. And also, this video will be available afterwards to catch up on, should you wish to do so. Okay, so this board then, Alasdair, who's it aimed at? What kind of person?
I think there's probably two main groups of people who will be using this. It's really great for schools, secondary schools. I envisage it will be really good for perhaps some cross-curricular projects where you might be working with some different subject areas to maybe monitor your air quality around the school and see maybe some of the impact. There's quite a lot at the moment about the real importance of perhaps carbon dioxide and other atmospheric conditions in schools for impacting focus and concentration. So it'd be really good for doing some projects there.
Yep.
But also for people at home who want to keep an eye on their own indoor air quality or in workplaces to perhaps trigger some changes they might want to make to their systems and just generally live a healthier environment to be in and just have some interest in seeing what's going on around them.
Okay, so I mean, we're talking about air quality here. I mean, we'll cover it more in detail, but this board just does things like CO2 and then VOC measurements, doesn't it?
Yeah, so it gives you, using a gas sensor, it will give you that estimated CO2 output based on some of the air quality readings it can give, along with temperature, pressure and humidity to combine together in a really nice environmental sensor.
Yeah, and it does do VOCs, does it?
So it doesn't give necessarily that output directly, but it gives you those estimations and that sort of thing.
Yeah, fantastic. And I know we've talked about schools though, but I mean, what kind of age range within schools would you be thinking? Is it, obviously, to me it feels like maybe a secondary age group?
Yeah, I think this is definitely secondary. I would see that probably from 11 upwards they could be using this in secondary school with projects in science or perhaps building some sort of housing for like a weather station kind of thing in DT, but definitely secondary school. Yeah,
great. Okay, so I'm just going to show you the web page here that we've got for the product. So this is what the board looks like. Again, Alasdair will show you more detail in a minute. The board costs between £30 and £26 depending upon the quantity you buy. And then this website's really useful. It describes more about the board. We've got some videos and things, but we also have this resource section at the bottom. I'm sure Alasdair will go over it, but this is where you can access things like the data sheet and some of the tutorials that we've created for the board. So yeah, if you head to the website, the product code is 5674, and there's lots of information available there. Okay, so is the next thing to sort of take a bit of a tour of the hardware itself?
Yeah, I think that would be a really good thing to do, just to show you guys on the stream a bit more in-depth detail of what's going on. So I'm just going to switch to have a look. So here it is. Here is the air quality board. It's give you a comparison with the microbit size. It's quite a nice compact little board, and the microbit slots in really nicely just on the top here. It just slots into the edge connector. We've got on it, there is some, let me have a look. Here's the little air quality sensor. So that gives out temperature, pressure, humidity. It uses a gas sensor to estimate carbon dioxide in the atmosphere, and also gives an air quality index output reading. And there's more detail in the data sheet on our website that Kevin just showed us for what that reading means, and I guess the kind of things like VOCs and other things that are impacting that reading.
Do you think people understand what a VOC is?
So VOCs are volatile organic compounds. So they're the kind of things that you'll find in perhaps cleaning products or on some surfaces or other bits that perhaps give some not quite particulate matter in the atmosphere, but those things that we might be breathing in just from everyday objects around us that they just happen to have on their surface, or in kitchens perhaps when we're cooking.
Yep.
that we can't see that are there, and perhaps don't realise the impact they're having.
And these VOCs are the kind of things that can cause contribute to asthma, aren't they? And those kind of things. So.
Yeah, those kind of things. So seeing kind of what your air quality is with the makeup of that, and some other gases as well that it will analyse and bring together in that one output reading, so you can kind of get a really good idea of the relative quality of your environment.
Cool. Yeah.
So that's that great little sensor there, all in one, does all that together. We've got an OLED display screen in the centre. You can see a bit more clearly there. That's a great little screen for just being able to perhaps display some of that data, so you can get a quick idea of what's going on. We've got some onboard memory, because one of the limitations of the microbit is that it's not got any non-volatile memory. That means that there's no permanent memory on there to save perhaps data that you're logging. So we've put some memory on the board, so you can store data permanently and log a good number of data entries if you're doing perhaps a bit of more of an analysis project in schools. We've also got a real-time clock up there, so you can accurately date stamp your data entries, or perhaps trigger using the alarm function when you might be logging that data, or do other things. We've also got, finally on this side, some other outputs, just some little zip LEDs. Those are our fully colour controllable RGB LEDs, which again are great for giving a visual indicator perhaps of the temperature or whether the air quality is good or bad at that moment. They're fully controllable by you, the user. And then there's some extra breakout points on the side for pins 0, 1 and 2, 3 volts and ground, so you could, if you were more comfortable perhaps doing some soldering, adding in your own sensors or other outputs, both analog and digital, to be able to do that. So those are the main features of the board itself. In terms of powering options, we've got on the back a 3 times AA battery cage, really nice available batteries. That'll keep that running, because it's a very low power board for a good week of running data logging if you've got a remote setup. But if you had a more fixed location, we've also got a micro USB port on the board for just providing power to the board. If you wanted to, when you're programming your microbit, you have to use the USB connector on the microbit itself. And finally, again, this would be really good if you've got a remote setup. We've got a solar panel input point, and if you combine that with some rechargeable batteries, you've got a really long time to be able to set that out in a location perhaps around your school or around your home, without the need to come back for a fresh set of batteries or a recharge.
Yeah. So you could use rechargeable batteries anyway, couldn't you?
Yes, you could. Yeah.
But yeah, should you want to sort of top those batteries up, you could use a solar cell input.
Yes, absolutely. Yeah.
And it's got a power switch, hasn't it? I think
power switch on the side,
Yeah.
but just to make it nice and obvious and save that power when you're not using it.
Yeah. And the microbit just plugs in.
Really nicely. So microbit faces this way.
Yeah.
So you can also, if you're reading perhaps on the screen here, you could also use the microbit display and the buttons really easily, so it's all together in one visible unit, nicely together.
And you've got all the normal sensors still available on the microbit. You would anyway, wouldn't you? So
absolutely. So perhaps one of the ones when I've been doing some testing of projects here is I've used the LEDs on the microbit as a light level detector, so you can kind of perhaps see how the air quality or other climate factors might vary between day and night, and so the microbit LEDs are great for that. And it's also got a few other sensors on board as well, like the accelerometer and other things if you wanted to look at things in perhaps a bit of movement. But the buttons are great as well for those inputs, just to be able to control and change what you're doing on the board.
Yeah.
So yes, it goes together really nicely in a really neat little package.
So you could use like button A to start taking readings and button B to stop taking readings and those kind of things.
Absolutely, and then perhaps another one set up to transmit all your data back to your computer if you want to do analysis, which I'll show you a bit later on in one of the software demos.
So we'll cover that.
Yeah.
Okay, great. So we've covered, I think, the main features there. And does it work with any version of the microbit? I know we've got this new sort of V2 microbit now and the original V1 version.
Yes, so it's compatible with both versions of the microbit, V1 and V2. I'll show this in the software demo, but we're trying to do quite a lot of exciting and interesting things on one board here with the sensors and the display and the things like the memory. So there's a bit of a slightly more limited functionality with the V1 microbit. You can still access all the features, but in a slightly different way. For V2 microbit, there's another software package available on Microsoft MakeCode that kind of just adds a bit more of a layer of extra functionality. But with V1 or V2, you've got full access to every feature on the board, but perhaps just in slightly different ways.
Yeah. So I want to say it's more enhanced with
more enhanced. Yes, that's a better way of putting it. Yeah, more slightly more enhanced. But I've been mostly doing everything with V1. All the tutorials we've got online are with V1, and that's looking at all the data outputs from the sensor. It's displaying all that data on the screen. It's logging data. It's transmitting it back. So there's nothing you can't do on the board with a V1 microbit. There's just some enhanced functionality if you've got a V2 to take advantage of the bigger memory capability and processing capability that's on there on the newer version.
Yeah, that makes sense. Okay, so next question is, what can you do with it? So we talked about cross-curricular projects, those kind of things. Have we covered that? Do we want to move on to the
I think maybe I covered things a bit early on.
Yeah.
Just with those projects you could do in school or at home, I think it would be a really great tool just for understanding something that perhaps we don't have a big grasp on at the moment of what our environment's like in terms of its air quality.
Okay. So is the next thing to maybe look at some of the examples you've got?
Yes, I think that'd be good. So I'm just going to switch to here. Hopefully you can all see MakeCode here. So this is perhaps for those of you who haven't done much programming with the microbit, or perhaps this is a new field to you. This is the Microsoft MakeCode programming page for the BBC microbit. This is the landing page you get to when you first come to makecode.microbit.org, and it's a really good way to get into programming. There are blocks-based. It's a blocks-based language, but you can also switch to use TypeScript or Python that they've got all in here, so you can really expand on it and change your learning as you go through when you get more comfortable with programming. So to start a new project, click on the big purple button there, and I'm just going to give it a nice name. And then once you've clicked OK, it brings up the editing page here. So you've got a whole list of the different blocks that you can bring in. So these are the ones that are all in there straight away. So there's things for controlling the display on the microbit, for their various inputs, and maybe some of those things like the logic and the loops that you can do. Very standard programming things. But to make things easier with controlling our board, we've created some custom extensions. So if you went to the extensions cog on the right and then searched for Kitronik, you see we've created a whole load of really helpful extensions for being able to use our products in a better way. And if you go down here, we've got two different extensions for air quality. So as I said before, there's one that accesses everything on the board, and that's compatible with both V1 and V2. And those enhanced features are found in the V2 only one. But we're going to go in the standard one for now, because that's all we need for getting everything done. So if you wait for a little bit, it'll install that extension, and we'll have a new category on the side, on the sidebar here. So there you have it, air quality with a nice little cloud symbol, so you can identify it easily. And in there we've got blocks for the RGB zip LEDs, for the OLED display screen, the real-time clock, the sensors, and then that data logging functionality for storing things in memory there. So I'm going to create a little simple program just to demonstrate how easy it is to do things with this. I'm going to display something when I press one of the buttons. So if I drag in an on button A pressed block, and what I'd like to do is display on the screen the current temperature, because that's a nice one to just get started. So first I go in here and I want to measure all the data readings from the board, from that little sensor, and then once I've done that, I am going to add a little pause just to make sure it's run through everything. That's often really helpful to do. And then finally going to the display, if I expand this, then I can select which of the 8 lines on that display screen I want to display it. So I'll display it on line 3.
So how many lines does the display have then?
So it's got 8 different lines, and it's 26 characters on each line, so you can display stuff on each of those, which is great because you can display date, time, temperature, pressure, humidity, air quality, and estimated CO2, and even your light level as well. So that's all those things you could display on there if you wanted to. To make it easier just to see what we're doing, I'm going to add some text field. and we'll just put temperature in there, and we'll give it some units as well. And then back in the sensors block, we'll bring in read temperature. We'll drop that just there. To save things to your microbit, it's very easy. Just plug it in with a micro USB lead. So I've got that just here. So I've plugged in with a micro USB lead my microbit, which I've also got plugged into my air quality board, which I'll show you in a minute. And then if you go down here in the bottom corner, what we can do is we can actually link in to that device through MakeCode. You'll see it brings it up in this list here. If we click connect and then click done, you'll see the little symbols change to the microbit logo, and that means we're connected directly to our microbit. So we can just download this program straight away and we'll be able to use it.
So in here, you're obviously starting your own program, and you've added in the package.
Mm-hmm.
If you do the tutorials for this, are they based in the MakeCode tutorial style?
Yes, they are. Yeah, I thought I might demonstrate in a minute, but you're right. This is the same environment that we'd be using.
The advantage of the tutorials being you only get the blocks that you are needed to do the tutorial program.
Yes, they're a really great way to start, because it can be a bit confusing when there's all these different blocks down here. So I'll show you that it is a simpler setup just to get you started in a really helpful way. Let me just switch back to the demonstration camera so you can all see. So what I've got here, you'll see I've got on the screen, I've got the current temperature displayed, and if I change that, you'll see it's just changing ever so slightly. If I put my finger over the sensor, hopefully you can see it's quite small.
Is that 23 degrees or 20?
23 degrees,
yeah.
And as my finger's on there, because I'm quite cold today, oh, it's going up and down. My fingers are quite chilly, but so it's just so simple to read from the sensor and to display that data on that little screen. Why don't I show you one of the tutorials, because this is something we'd go through in actually one of the tutorials.
Do we have any of doing a graphing or anything?
So with the V2 microbit, there is some of that extra functionality, enhanced features with the OLED display. You can plot simple graph on that display.
So that's the V2 only.
On the V2 only.
Yeah,
so there are some of those extra features like that. You can draw some shapes. You could build up a little display table, and you can plot simple graphs.
I know when we were doing the last tech talk with Dave, when we were doing the OLED display board, that was one of the things we were doing, was doing some graphing. Some
graphing of those. Yeah. So yeah, graphing something like humidity, or just seeing it perhaps change live over time, or plotting points every now and then. Yes, you can do that with the V2, but you can still display all of your output data on those different text lines with the V1.
Cool.
I'm going to show you now one of the tutorials. So it'll be doing a similar thing to what I've just shown you through MakeCode. So if you go to the bottom of that page, what we've got is the read temperature, pressure, and humidity. So if you click on that, it'll open what's now a familiar environment to you. It's the Microsoft MakeCode page, but it's a bit of a different setup, in that it just takes you through step by step how you might do that programming that we just talked about. So it gives you a welcome page that tells you what you're going to be doing, and then there's instructions just to take you through exactly what you need to do. And rather than all those blocks that we saw a minute ago, it's just got the ones that we need for running this tutorial. So there's none of the extra ones, there's none of the extra confusion that you might find.
So this would be a good way for a student to learn about the features of the board in a much more controlled environment, or simpler interface.
Yeah.
And then if they did go and do their own projects later, they'd still know what they were doing or what to use. But like, from the learning point of view here, they're not confused by 200 blocks to pick from.
Exactly, yes. It's really good for getting you started and to give you that confidence to go in later. And if you get stuck, there are really little helpful hints to tell you what your program should be looking like. And as you just go through step by step, it'll take you through, and you'll end up with a similar setup to what we just showed you in that initial demonstration. So there's 4 of these. There's this one that looks through the temperature, pressure, and humidity. There's one about using the OLED display screen. Then setting the date and time, and finally data logging with it. So if you combine all those together, and then perhaps reading things like the gas sensor as well to get that actual air quality. Then you could combine all the outputs of these tutorials to have a great little monitoring station.
Yeah. Can you do like the live logging functionality within the live graphing functionality within?
You can. You can't do the live graphing. The MakeCode. I might as well show you that now. Does have a feature.
I'm asking lots of questions. I've not briefed you.
That's all right. So MakeCode has what's a really helpful built-in setup for transmitting data across to it from the microbit. And if you're just reading one output, perhaps like the light level on the microbit, you can watch that graphing live.
Yeah.
Because we'd be capturing a lot of data at once, they haven't yet, I think, added that functionality. The Microsoft haven't added that functionality themselves to MakeCode yet to graph multiple outputs.
Okay, so but you could graph one of the outputs, could you?
Yes, I believe so. You could graph the temperature changing, or you could graph the actual light level, or your humidity, or something like that changing over time.
Yeah. So people haven't seen this before. The actual main screen you see there with the blocks on, that becomes a like a graph, doesn't it?
Yes. Yeah, it does. What I'm going to do is I'm just going to log some data quickly on my microbit, which you're not seeing off screen, and then I'll show you how that links up together. So I'm just going to go back to the home page and open a pre-prepared logging one here, that's nice and cleanly set up. You can store on the board 1,000 different data entries, which should give you a really good data set for doing some really good analysis.
Yeah. So I guess if you were, you're trying to do, depends what you're trying to measure, I guess. Some environments you might want to be logging really on a regular basis. On a different basis, you might say, actually, we want to look at the air quality every half an hour within a school, and that would last for a long time, wouldn't it? Those readings. Yeah.
It's definitely, so you've got that range of things you could do. So I'm just going to plug in once again with that micro USB cable. Plug in my microbit, and you'll see that it's connected here because the microbit logos come up. And I'm going to press one of the buttons. So I set it up to when I press button A, it will transmit the data across from the microbit. As you can see, it's brought up a new button here. It's a show console button. So if I click that, what we've got is a new screen. Press it again, you'll see more data appear underneath. So what I'm doing is reading out from my microbit a whole bunch of data. So it tells us it's the Kitronik data logger, the air quality and environmental board. I've added my name and a subject. That's one of the blocks that you can do. And then we've got different titles. So we're logging date, time. Let me zoom in, maybe.
Yeah, that might help people.
Apologies. Let me just zoom in a bit so you can see what I'm actually talking about. So what we've got here is all the data. We've got a title and some. Perhaps you want to add your name and perhaps the subject you're doing. We've got different title headings for what we're logging, and then you've got the date, the time, the temperature, the pressure, the humidity. This index quality score is what's here, and the estimated CO2 output and the light level. So
these delimited fields then again.
Yes, so you can see they all looks a bit confusing here at the moment because there's just lots of semicolons. But what this actually enables, if I zoom out again, you can see up here in the top right, and up here, so we can export this data. So if I click that, what it's done down at the bottom, which I'll open, it's created a CSV file, which means you can open it up in a spreadsheet program like Excel.
Yeah.
Actually, sorry.
See that one?
Let me just make sure you can see it. You can also download it as a text file, which I'm just going to show you now. Please excuse me. We are trying a new setup today, and
technology is beating us.
Technology is always ready to trip you up, isn't it? Should better see Excel. hopefully you can see here we've got an Excel document, and then underneath here is the text file that I've downloaded. What I'm going to do is, if I go back into Excel, you can go to Insert, so to Data, and you can insert data from a text file. So I'll go to my Downloads folder, which is where that will have just arrived. You can see here it's this microbit console output, and because we had all those semicolons separating everything, made it look confusing online. If we click here on the delimited section and then tick semicolon,
it will separate.
What you see, it'll separate all that data out. If I click next again and then finally finish, it'll import all that data for us. So what we've got are different fields. We've got the date, we've got the time. What we've got, actually, we've got two different data sets here, because I logged it out twice. Let's zoom in a bit for you. There we go. So we've got the data set here, the column for the date, and then the time, the temperature, pressure, humidity, index of air quality, the estimated CO2, and the light level. And then from here, it's a really easy point with the spreadsheet program that you're familiar with, to be able to, I guess plot graphs to output other results that you might be able to then use to drive your projects and other things that you're doing.
So I mean, things I could imagine being quite good. You might say, actually, we want to look at our air quality in the classroom and how it varies during a day. Yeah. You may have students who actually, because it's battery powered, want to take the board with them and walk on their route home from school. Yep. Does the air quality, is it better or different when they're in a park or when they're by the side of a road, or those kind of things? Yeah. Like you say, maybe it could be a whole cycle of a day in a room. So like, or where they sleep. Is the air quality different when they're sleeping? As they're expelling CO2 with the breathing, those kind of things. Yeah. You might take it around a house, or look at like, is my air quality worse in the living room when the gas fire's on, or there's lots you can do, isn't there? Yeah. It's such a big subject now, really. It could be linked into the sort of science and health aspects of living, biology, those kind of things. So we see it as quite a cross-curricular and very topical board. Yeah. Obviously, it's not the cheapest of boards, but it's got a lot on there. And the reason on the range drive, in fact, are these sensors that measure these CO2 and that, they are expensive. They are. And obviously we've had the display on there, but we do feel that the display adds quite a lot to the experience of using the board. Absolutely, yeah. It gives this board's just really versatile in enabling lots of inputs, lots of outputs, and just making it an all-in-one package rather than having to add extra things in to perhaps give you that visual output through a screen, or add more sensors in afterwards. By having it all together in one place, makes it much better for those projects. Is there a difference between the amount of data you can log with the version 1 or version 2? Does that not matter because we're doing it all onto the onboard chip? Yeah, because it's all on the air quality board itself. That memory capability is exactly the same, so you can store those 1,000 entries whether you're on the V1 or the V2. Yeah. It's really only some of those features with the display screen itself that's the difference with the enhanced functionality on the V2. Yeah. And if we had people come to us and go, well, I'd want to do more than 1,000 readings, would there be an option for that? Or so that's really limited by the actual chip we've got on there itself. So it's a 1 megabit chip, and with the size of the when you're logging date, time, temperature, all of those different factors that we just showed you, they combine really nicely to just give you about 1,000 entries worth of space. So that's reading each of the different sensors. Yes. Okay. Yeah. Could you say I don't want to read some of the sensors, or does it not work? No? Yeah, you can do. So that is one of those V2 enhanced features. You can select that perhaps you might only want to log the temperature and humidity and the estimated CO2. So you can change that. And then you get more entries. Would you more data? I think it's still limited to that, just because of how the software works with that. But we felt 1,000 is probably a good number. So that's I think it's just over a week's data. If you're logging every half hour or so, you've got a really good amount of data you can pick up. And did you say you can't use it with the graph function in
In V1 you can't.
You can't.
In the graph feature on MakeCode.
Yeah.
So you could do that if you had a single output. Perhaps if Microbit add more to that functionality, then you may be able to get more.
But if I wanted
at
to
once.
graph, I don't know, CO2, could I graph that live?
I believe you should be able to. Yeah.
Okay. Yeah. So I mean, I could imagine that being nice for a classroom where you might introduce different substances to the sensor.
Yeah. And see
maybe the science lesson.
Yeah.
And see how that impacts on what's going off. Yeah. Okay. Great. Trying to see if there's anything else that we meant to cover but haven't. So I mean, obviously the examples you've shown there are all using MakeCode with blocks.
Yeah.
Is it possible to use other coding languages, or Python is very popular, or have we specifically stuck to the block programming environment?
So you can access a written language through MakeCode as well by switching to the JavaScript mode or the Python mode, but that's all within MakeCode.
Yep.
If you actually wanted to run MicroPython, if that's what more you use, unfortunately, because of the memory limitations of both the V1 and V2 Microbit, MicroPython as a build takes up a lot more space on the Microbit beforehand, and it's just not possible to run all those features together.
Okay.
It's too much space is taken up by the initial MicroPython build, and then what we write is the software on top of that.
Yeah.
And it just takes up too much space, unfortunately.
I suppose an option there is, we have got the Raspberry Pi Pico now, which is a board we've started to design boards for.
Yeah.
I mean, one of the advantages, I guess, of that board, I mean, we're going a little bit off Microbit here, but that board already has onboard memory, doesn't it?
It does, yes.
And it's geared towards MicroPython.
Yes.
So, I mean, it's not saying we'll do it, but one of the things we might look at is maybe having a version of this board that's more suited to the Pico, and then that would be more suited to people wanting to learn and code in that MicroPython.
Exactly, it's a perfect the Pico is a perfect environment for writing that MicroPython code. Yeah.
The downside to the Pico, I guess, is you don't have the onboard sensors that the Microbit does and the onboard wireless functionality.
Yeah.
But it's got a lot more going for it in different ways. So it's I guess I'll say horses for courses, but it depends on what you're trying to do.
Yes.
So that might be something we cover later on to sort of bridge that MicroPython gap, really.
Yeah.
And I think this board, to me, it feels like something that you would use well in secondary. I can't see this being used really in a junior school environment, unless you've got a very competent teacher that's good, can. Not saying it's impossible to do it, but I think to me it feels more like that kind of 12, 13, 14-year-old kind of project.
Yeah, I think you're right. It's more suited and targeted at that age group who've perhaps got it linking you more with that kind of thing in the curriculum, whereas in the primary school that wouldn't be covering those sorts of health impacts, I think.
And the Excel manipulation of data and graphing and those kind of things would be well suited to that, really.
Definitely, yeah.
Okay, I mean, could you explain anything about the gas sensor setup then? Because does that take a little while to do, or is it super simple?
Yes, so it's very simple in terms of the programming of it. There's just two blocks. There's just two blocks where you set up the sensor and you set up. Here we go. So if I go back to that initial project that we had open, Air Quality 1. I didn't include those at the time, but if you go into the sensors, there's one here that's called Setup Gas Sensor, and one that's called Establish Gas Baseline and Ambient Temperature. Now those blocks are both required, and it's really great to put those into the on-start block that you've got in MakeCode, because that means they run right at the very beginning.
Well, we've disappeared on here.
We have disappeared. I'll come back to our faces. There we go. So those are just the two blocks you need. So it's really simple for you, the user, to program. But what that will initiate is a 5-minute process where the gas sensor is set up, so it sets what temperature the plate inside is going to go up to in terms of sensing.
So, sorry, you don't talk about this plate inside there. Does a gas sensor work in a certain way then? Is that right?
So it uses a heated plate
Okay.
that's set to a particular temperature, and depending on that temperature, you can sense different gases, and it will be on for a certain length of time. So we've set it to a level to run automatically, rather than you having to set that, which will give you that good broad spectrum of gases you'd find. And once it's reached that point, we then want to run a measuring cycle, which is what this gas baseline section is. So that runs over 5 minutes. and it takes lots of readings and then averages those out, and it gives us a baseline level of what the environment is that you're in. So it's really great to put that in an area that I guess there's perhaps some fresher air if you've got that, or so it's near a window or something that is a.
So would you do this every time you run a program, or is it just a sort of one-off thing you would run?
So each time you put it into a new environment, it's good to do it,
Right.
and then from that point, it will be able to give you much more accurate relative results to the environment that you're in, and it'll show you those big changes and the effects of the spikes.
Okay, so I suppose you're looking at the readings are relative to the initial baseline it's set.
Yes, yeah,
Okay.
so you've got to calibrate it again for the different spaces that you go in. But if you can find that fresh, perhaps an area that you know and can sense just with your feeling. So perhaps don't put it in an area that's got lots of smoke, or you're spraying lots of chemicals really clearly.
I suppose that's why they call it an equivalent sort of reading, then, isn't it? It's
Yes.
equivalent to some known
So a known baseline.
And then it's better or worse than that was.
Yes, yeah, which can really help. So it's a good way of checking it once you've done that is perhaps if you breathe on the sensor, which as you know we breathe out a much higher proportion of CO2 than we're breathing in. So you'll get that really intense period on the sensor. So you should see a spike in both the air quality decreasing and the CO2 going up. And the humidity increasing as well, because as we breathe out that damper air. So that's a good test just to make sure you've got things set up nicely.
Great.
I think we've got a question come through on the chat from Martine. Thank you.
So do you want me to read it?
Yeah.
So it says, nice new board. May I ask why you say estimated CO2 levels and how accurate is it?
So we've called it estimated to be really clear that this isn't a full carbon dioxide sensor. Those are a lot more complicated and unfortunately more expensive.
Yeah, very expensive.
So to make this a good product for schools and for individuals without adding a big cost, we've gone with one that provides an estimated output. So it's reasonably accurate. Obviously it won't be as accurate as a proper CO2 sensor, but because I've used a lot of data that we've gathered from other sensors and using good scientific data as it tracks against things like humidity and temperature and the air quality gas readings that we're getting, then you can estimate reasonably accurately how the carbon dioxide will vary as well.
Yeah. Like I say, it's to a sort of known baseline.
It's to that known baseline.
It's not going to say the CO2 is a specific known level reading.
No.
But we've looked at some of those different sensors before, and they are very expensive. I think we'll take the product out of reach for use in most schools.
Yes, which is not what we want to do.
No. So if you had two boards, then just my thinking here, and if you wanted to get the same kind of output readings or numbers, would you have to calibrate them next to each other then to start with?
Yeah, so they've got the same baseline area
Okay.
to get that initial gas sensor and ambient temperature readings of the environment.
So if you had a class full of students all going to go off and take readings around school and write down what time those readings were taken and where they were, you'd want to calibrate them all in the same.
Yeah, perhaps if you did it all in that initial classroom, next to a window, something like that, so they're nice. It's got a good stream of air coming past. Then that'll give you that really good baseline, and they can work out from there with all the different environments they take it into.
Yeah.
But then they should be giving out good matched relative results.
Fantastic. Yeah. And you could use Bluetooth readings, can't you? Can you make sort of kind of wireless transmission of data back, I guess?
Yeah, with the radio functionality on the microbit, you could be sending that data back to another microbit that you might have hooked up somewhere else, or talking to each other with perhaps that kind of project to compare readings with one another.
Yeah. Yeah, so I mean, one of the things I think we want to look at really is taking these into more schools. Obviously, with COVID, it's not been that easy for us to go into schools and do probably some of the real world example with students, and we can see the value. And we've obviously spoken to teachers while we've been designing the board, haven't we, to make sure that we feel it covers off the things they would want to do. But I would expect over time it might be something where we add more resources and examples of how they've been used in real classrooms.
Yeah. That'd be something really nice to do.
Okay, so we've got another board. I hope to use one of these on the drive through my son's school with an LED readout, so parents can appreciate their impact and reduce the amount of people driving. So drive through at my son's school. I guess it's kind of drop off where the students dropped off. So I think what we're looking at here is, looking at the impact of driving on air quality.
Yeah, I think that'd be a really good feature of it. You could either, I guess, if you wanted to hook a bigger output, big LED perhaps, if that's what you're foreseeing, you could perhaps use one of the pin 0, 1 and 2 outputs, or if it's just wanting to show on the perhaps the zip LEDs themselves, you could give that, perhaps you could change the hue of it to show whether it's currently good air quality, perhaps with a green all the way up to a red sort of output.
Yeah, it would be good if you could, I suppose, have some larger display elsewhere that was. I wonder if you could do that on the actual, use like a computer running MakeCode and connect one to it. Might be.
Or if you could be radioing, perhaps that would be a good time to use the radio feature if you've got something monitoring and then another one streaming back to. So that if you were just specifically looking at the CO2 or the air quality data itself and not so worried about displaying the other things, if you're just transmitting that data and displaying it on a computer somewhere else, it could be really good.
Is that something we've seen impact the readings, like emissions from cars?
I've not taken it out into the car park. Actually, I did run it inside our laser cutter while it was doing some etching, which increases a bit more of the CO2, but also perhaps some of the smoke coming off, or some of the chemicals that come off some of the surfaces of our acrylic or wood. So yes, you could see definite spikes in it and an increase when you're measuring that data.
It's certainly something we'd expect to see impact on the air quality readings.
Yeah, definitely.
For sure. Hence, there's a big drive now, isn't there, to have like ultra low emission vehicles and clean air zones and all those kind of things. I mean, I think everyone knows, don't they, that probably more people drive to school than they should.
Yep.
I live in a village, and a lot of people still drive to drop the kids off, which is slightly, I guess it could be avoidable.
Yes, that kind of thing. So thank you for sending those comments. It'd be interesting to hear how your project goes if you get that running.
Okay.
Really good.
Brilliant. I don't know if there's any more questions, Mark, or is that kind of it so far? We're running out to sort of nearly 45 minutes. Amazing how fast the time goes doing these. And I hope people have enjoyed this kind of new format. Up until now we've been having to do it kind of virtually because of not necessarily that easy to have us both in the same room at the same time. We do want to improve our backgrounds and our setup over time. And these we'll continue to do these kind of tech talks. Hopefully, maybe every 2 weeks, maybe a bit more regular, depending on how we can fit them in, and also the products we want to cover. But if people do have any specific subjects they would like us to cover, by all means send us some comments through and we'll try and add that to the list of talks we want to do. I'm sure this is a kind of board we might come back to with more talks maybe later on, or particularly as we maybe add more products into this kind of this range. There's one question I was thinking myself, and it had been asked. We do our greenhouse product, don't we?
Yes.
And I know at the moment this is a separate board, isn't it? But is there a way of adding this sort of air quality reading into that growing environment, or would that be something we would have to develop as a separate product?
So I guess there are definitely similarities between the two boards. I was thinking about that during the design. One of the extra things with the greenhouse board is the extra control features you get for running your smart greenhouse. If you had so we provide the smart greenhouse kit with a nice little contained injection molded greenhouse set, which just has space to the environmental board. But perhaps if you were using the parts from that kit to build into perhaps your own larger enclosure for growing things, then adding this board in as well.
That makes sense.
Would be good. It wouldn't fit into the space that's there with the original smart greenhouse kit, but all those parts can be used perhaps in your own setup that you're creating for a larger, small greenhouse or.
So if a student, or in design technology, maybe laser cut some kind of greenhouse enclosure that was bigger for bigger plants, we could also add You could add one of these in to see how things change there. To measure the air quality as it's growing.
Yeah.
And I guess what we'd expect there would the growing would improve air quality, would it? Was it?
I think plants take in CO2 during the day, don't they? But they expel it at night. So perhaps you'd see that variation between day and night, and how things are affected there.
It certainly would be interesting to see. I think. Okay. Well, great. I hope everyone's enjoyed it today. I've found this out quite good. So I'm sure we can improve it over time, but I hope you've all enjoyed it, and we'll see you at one of our talks in the future.
Yes, thank you very much for joining everyone.
Great, thank you. Back screen.